So in this video, we will create a delete method in Circular Doubly Linked Lists. So we will use the algorithm that we looked at in previous lecture. So if you haven't watched the previous lecture, and I advise you to go back and watch it, because here we will create a method based on the algorithm that we discussed in previous lecture. So inside our Circular Doubly Linked List class over here, after the search Circular Doubly Linked List, which we created in our previous lectures, we will create a new method here, which is called delete node. So here I will declare our method like this, def delete node, and by default it takes self parameter, and according to our algorithm it will take location parameter. Then, as always, the first step is we are checking head value. So if self.head is none, we print out saying that there is not any node to delete. Otherwise, we are continuing to check location parameter. So if location parameter equals to 0, so it means that we want to delete a node from the beginning of Circular Doubly Linked List. So we know that deleting a node from the beginning of Circular Doubly Linked List has two cases. So the first case is in which we have only one node in our Circular Doubly Linked List. So how can we check that if we have only one node in our Circular Doubly Linked List? We know that if we have one node in the list, so both head and tail references have to point this node over here. So if self head equals to tail, it means that we have only one node in our Circular Doubly Linked List because both head and tail references point to this node. So in this case, according to our algorithm, we need to set previous and next references of first node to none. Then we need to set head and tail to none. So by setting previous reference and next reference to null, we are deleting the reference that points to itself. So we are setting previous to none, then we are setting head next to none. Then we need to change head reference to none and tail reference to none. So by setting all these references to none, we are deleting all references that points to the first node in our Circular Doubly Linked List. Now in this case, we don't have any reference to the first node in the list, so the first node becomes eligible for garbage collection. So the garbage collector comes and deletes it from the memory. Now the next case is if we have more than one node in our Circular Doubly Linked List. So in this case, the first step is we need to change reference from the head to the second node. So we know that if we set head to self head next, we are creating a link between head and the second node. Then we need to create a reverse link between the second node to the tail. So we will set head previous to tail. And finally, the last node's next reference has to point to this node over here. So we will set self tail dot next equals self head, because right now head stores the location of second node. So by setting this reference over here, we are creating a link between last node and the second node in our Circular Doubly Linked List. Now with these steps, the first node becomes eligible for garbage collection, so the garbage collector comes and deletes this node from the memory. Now the next step is we need to check again location parameter. So if location parameter equals 1, it means that we want to delete a node from the end of Circular Doubly Linked List. So in this case, we have also two cases. The first case is in which we have only one node in our Circular Doubly Linked List. Here, the steps are same as the way that we are deleting the node from the beginning of Circular Doubly Linked List. So I will just copy this code from here and paste it here. Now the second case is we have more than one node in our Circular Doubly Linked List. So how can we delete a node from the end of Circular Doubly Linked List in which we have more than one node? So in this case, the first step here is we need to change tail reference to point the node which is before the last node. So I will set tail to self.tail.previous. So we know that previous reference of tail points to the node which is located before the last node. So by setting tail to this reference over here, we are creating a link between tail and the node that is located before the last node. Then we need to create a link between this node and the first node. So I will set tail next to head. So by doing so, we are creating a link between the node that is located before the last node and the first node. Then finally we need to create a reverse link from the first node to this node. So we need to set head previous to this node. So now the tail points to this node, so we are setting it to tail. So by doing so, all references that points to the last node are deleted. So there is no reference to the last node, so the last node becomes eligible for garbage collection. So the garbage collector comes and deletes this node from here. So we successfully deleted the node which is located at the end of Circular Doubly Linked List, in which we have more than one node. Now the last case is we are deleting a node from the middle of Circular Doubly Linked List. So as we said before, in this case we need to loop through until we reach the node that is located before the node that we want to delete. So in this case, I will create temporary node which is called current node and set head value to it because we will start from the first node. Then I will create index variable over here and set it to 0. Then inside while loop, while index less than location minus 1, we are setting current node to the current node next, and we are increasing index by 1. Then when we reach the location minus 1, we stop over here. So here we need to create a link between current node and the node that's located after the next node. So I will set current node dot next to the current node dot next dot next. So this reference returns the physical location of the node which is located after the next node. So by doing so, we are creating a link between these nodes. Then we need to create a reverse link between the node which is located after the next node and current node. So current node dot next dot previous will be current node. So with this, all references that points to the next node are deleted, so the next node becomes eligible for garbage collection. So the garbage collector comes and deletes this. So at the end, I will print out saying that the node successfully deleted. The node has been. So with this, we have completed our deletion method. So now let's see how this is working in practice. So here, as always, we are creating a Circular Doubly Linked List based on the methods that we created in our previous lectures. Then we are printing out the Circular Doubly Linked List that we created over here. Then after this print statement, I will call our delete method. Now after calling delete method, I will print out our Circular Doubly Linked List one more time. So because by doing so, we can see the difference very clearly. So let's run our code. Here you see that initially our Circular Doubly Linked List is like this. Then after calling delete method, it says that the node has been successfully deleted. Now here we see that the first node is missing, which means that we delete the first node from the Circular Doubly Linked List. Now let's run our function for the location parameter 1, which will delete the last node from the Circular Doubly Linked List. So let's run our code. So in this case, you see that once again we have Circular Doubly Linked List like this, and after deleting, the last node is missing. So we have successfully deleted the node from the end of Circular Doubly Linked List. Now let's call it for example, location 2, which will delete the third element in the Circular Doubly Linked List. Now let's run our code. As you see, 2 is missing. So third element is missing. Now if we want to delete a second element from the Circular Doubly Linked List, we just need to call our method with any given minus value. If I save it and run it, you will see that the second node, which is 5, is missing. So if you run it, you see that the second node gets deleted. Now let's see what is the time and space complexity for this method over here. So here, as always, we will start from the first line of the method. So here, as a first step, we are checking the head value. So we know that checking head value takes O1 time complexity. Then we continue to the else condition. In else condition, we have another if condition, which is checking the location parameter. So inside if condition, we have another if condition. So if we look at this if condition very carefully, we see that, so here we are just comparing two variables and setting the references to none. And in the else condition, so we are just updating the references over here. So this means that updating references takes O1 time complexity. So this part over here will take O1 time complexity, and else part also takes O1 time complexity. Now let's continue to the next part of this if condition. Here again we are doing the same operations, which means that these two parts also will take O1 time complexity. But when we reach the last part of this if condition over here, we see that we are creating temporary node and temporary variable over here. To create temporary node and temporary variable takes O1 time complexity. But at the end, inside this else condition, we have loop over here. So looping through any given collection takes O(n) time complexity. That's why this part over here will take O(n) time complexity. And the last part, which is updating the references, takes O1 time complexity. Now, if we combine all these complexities over here, we will get O(n) time complexity. So deleting a node from the circular double linked list takes O(n) time complexity in the worst case, because when we delete a node from the middle of circular double linked list, we have to traverse through circular double linked list. Now the space complexity is O1 because here we are just creating two temporary variables over here. That's why it takes O1 time complexity. Now this is all for this lecture. So in this lecture we have created delete method for circular double linked list. So we know that we have three cases for deleting a node from any given type of linked list. That's why we have combined all three cases in this method. So hopefully everything is clear now for this method. Now in the next lecture, let's see how can we delete entire circular double linked list.